Hello guys, welcome to my channel and my new video. Today you are going to learn lots of stuff. So please do like this video and don't forget to share this video with your friends also so that they can learn too. If you have just stumbled upon this video, don't forget to subscribe to my channel. Also hit the bell icon so that you are immediately notified when I post a new video. Happy learning! Hello friends, so welcome to this new video of BITSAT series. So I've picked up 5 questions from magnetism, moving charges and magnetism, that is due to current. So of different BITSAT here. So let's begin with the first one. So it says the cylindrical conductor of radius r carries a current I. The value of magnetic field at the point which is r by 4 at a distance from the surface. This is very important. Students usually don't see this part, that is 10 Tesla. The value of magnetic field at the point which is 4r distance outside from the surface. This is again important. Now I have taken these questions just for the revision of different formulae. So let me tell you the formula required for this. B inside, this is a cylindrical conductor, so B inside is given by mu naught by 4 pi into 2I r by r square. So r, this small r, is the distance from the center, that is the axis of the cylinder, to the wherever point inside the cylinder. Cylinder is there, from the axis a little more wherever there was. So that is, this is the formula for B inside. So do make a note of it. And again outside is also required in this question. So B out is given by mu naught by 4 pi into 2I divided by r dash, where r dash is again the distance of the cylinder. If the cylinder is this way, this is the top view, and it is outside, from the axis to that point is r dash, right? So these two are the formula which is required for us in this question. So let's find out B in first. So B in, they have given actually the B in, the value of that is given, and we are supposed to find out the value of B out. So B in by, let me divide the both of them. B in by B out is equal to mu naught by 4 pi into 2I r by r square, where this capital R is actually the radius of the cylinder, right? Into this will go to the numerator, so 4 pi times r dash divided by mu naught and 2I. Yes, so we get this when I divide B in and B out. So mu naught and mu naught gets cancelled, 4 pi and 4 pi gets cancelled, 2I and 2I gets cancelled. I am left with B in divided by B out is equal to, here R is left, so R, here on R dash is left, R dash divided by capital R square. So that is R square. Now what is R? R is the distance. They have given r by 4 is the distance from the surface. If cylinder is this way and the center is here, this distance is r by 4. So what is this distance? 3r by 4, right? So small r is 3r by 4. You can also write it as r minus r by 4 and later become 3r by 4 into r dash. Now r dash, I have told you earlier that it is from the axis to the whatever point outside. So that is r dash. Here in the case you have to cover a distance of capital R first and then extra 4r, because that is what is given, right? So 4r plus r is 5r divided by it is r square, capital R square. So r square, this gets cancelled, and I am left with 5 3s are 15 by 4, right? And B in by B out is 10 by B out. B in was given to us, 10 by B out is equal to 15 divided by 4, and which implies that B out is equal to 40 divided by 15, that is I can divide it by 5 8s are 40 and 5 3s are, that is 8 by 3 Tesla. So option B is perfectly correct, right? So let's get to the next question, which says a cyclotron frequency of an electron gyrating, that is nothing but revolving, in a magnetic field is 1 Tesla is approximately. They are asking what is the frequency. Now actually either you can I'll tell how to derive it first, but later it's better if you remember the formula so that no time is wasted. So actually basic formula we need is 2 pi time period of a revolving electron is 2 pi r by v, and we also know that r is equal to mv by qb. This is what we know previously. Here we just need the value of r by v, which we can find out from this, that is r by v is equal to m divided by qb. So I'll substitute over here, time period is equal to 2 pi into r by v, that is m divided by qb. What is frequency? Frequency is 1 by time period, right? So 1 by reciprocal of this, that will be qb divided by 2 pi m. Now it is electron, so it is eb divided by 2 pi m. They have given b, we know e, we know m, we know 2 pi. So can't we calculate the frequency? Yes, we can. So that is E is 1.6 into 10 power minus 19 times magnetic field is just 1 Tesla, so that is 1, and if I divide it by 2 pi m, that is 2 into 3.14 into mass, that is 9 into 10 power minus 31. It is 9.1, but for sake of simplicity I am writing it like this. Now let's see how to proceed. Now it is 1.6 and this is 3.14. For the moment let me approximate it to 3.2 because 16 2s are 32. So this and this will cancel out to be 2, and it is 1 divided by, now only 9, 2 and 2 is left. So 9 into 4 is 36, so 1 by 36 into 10 power that is 31 minus 19, so that will be 2 and 1, that is 12. Now see what I do. 1 by 36 is it is difficult to divide, so approximate it to 1 by 40. You know 1 by 4, right? So that is 0.25, and 1 more 10 is divided, so 0.025 into 10 power 12. That is, if I shift 3 decimal places, 25 into 10 power 9, so 25 gigahertz. So something approximately to 25 gigahertz should be our answer, and that is only option D, which is 28. So that will be obviously true, because if we have increased the denominator, if you decrease it, the whole value will increase. So it should be something greater than 25, which is 28, which is perfectly correct. So that's how we solve the question. Now let's see the next question, which says an electric field of 1.5 kilo Newton per coulomb. It is volt per meter, both are same. So 1500 volt per meter, and a magnetic field of 0.4 Weber per meter square, that is nothing but Tesla itself, act on a moving electron. What is the minimum uniform speed which is required? So most of you will know, but just for the revision, it is actually V is equal to E by B. This is actually called as velocity selector equation. Velocity selector equation. So that's what we have to use. So E is given to us, that is 1500 divided by 0.4, 4 into 10. So that is 4 3s are 12, and 3 4 7s are 28, and 2 4 5s are, and 1 extra 0. So 3.75 into 10 power 3, 3750 is the answer. So 3.75 into 10 power 3 meter per second. Option C is perfectly correct. Now let's see the next question. A straight wire of mass 200 grams and length is given. It carries a current of 2 amperes. It is suspended in mid-air. So a force must be acting by a uniform magnetic field which is horizontal. So what is the magnitude of the magnetic field? Now what they are saying is there is a wire which is suspended in mid-air. So and it is there is a force acting, that is magnetic force, due to which it is just suspended, it is not falling down. So we have if we use the left hand thumb rule, the Fleming's rule, that is FBI. So if I take B is horizontal, so let me make B horizontal. This is B, and this is coming out of the plane of the paper. So this is B, this is FBI, this is B, this is I, and force is acting upwards. So that is true if force is acting upwards, and we know that the force due to gravity, that is mg, always acts downwards. So F and mg are opposite to each other, and that is mg is equal to BIL. So this is the reason why it is just suspended. If either of them was lesser or greater, then it would fall or go up. So that is depends on the force, but here it is just suspended, so these forces must be equal. Now they want the magnitude of B, that is B is equal to mg divided by IL. So m is given to us as 200 grams, that is 0.2 kg into g is 10 divided by I is 2 again, and L is 1.5, that is 3 into 3 by 2. I will send the 2 upstairs. So 0.2 into 10 is 2, and 2 is there in the denominator, and it is 2 by 3. 2 by 3 is 0.66, approximated to 0.65, and option D is perfectly correct. Now the last question, which says a current carrying circular coil is bent so that it converts into a double loop, both the loops being concentric and carrying current in the same direction. If B is the initial magnetic field, what is the final magnetic field? This is again a formula based question. B is equal to, we know that mu naught I by 2R for at the center, B at the center of a loop, you can multiply by n. If starting it was actually just one loop, so n was 1, so it was just mu naught I by 2R, and B dash is equal to mu naught I into 2 divided by 2R dash. Now we have to see how R dash is varying, how it changed. Be L, so L is equal to initially 2 pi, and the radius initially was 2 pi capital R, right? Oops. Okay. And but the length remains same, right? But only we convert it into a double loop, so that becomes and it is twice, so 2 into 2 pi R dash, but length of the wire remains same. So we can equate this to 2 pi capital R is equal to 4 pi R dash, so twice, and R is equal to 2 times R dash. So this is the relation we got. So B dash is equal to 2 times mu naught by 2 R dash according to the formula. So let's divide both of them. This was initially B itself, and this was 1, this n was 2, so B dash divided by B is equal to mu naught I by R dash into 2R divided by mu naught I. So mu naught I and mu naught I gets cancelled, so it is 2R divided by R dash. R dash is actually, R dash is equal to R divided by 2, this 2 goes upstairs into 2, and RR gets cancelled, and it is 4 times. So B dash by B is equal to 4, which implies B dash is equal to 4 times B. So option D will be our correct answer. So thanks a lot for watching this video. Thank you.